So good morning, everyone. So we'll start with, this is the second session on EM wave. We started with yesterday. And again, let's quickly go through what we did yesterday and very brief. To understand wave, EM wave is not we can see, but there's something similar, a similar form of wave, which is a wave traveling on a string. This is something which can be seen, which can be visualized. And what we understand in case of traveling wave, if we create any disturbance here, which is in form of a displacement, the disturbance what we create, it keeps traveling on the string. So this travels along the string because string forms the medium. Another way to understand is energy given at this point, this energy also travels at different points on the string. So any wave, it transfers displacement to surrounding point with a time lag. So what happens, whatever distance we create at source, similar sort of disturbance gets transferred to the surrounding points in the medium with a time lag. And the time lag, greater the distance of the point is, greater is the time lag. And energy also gets transferred. So that's what it is. Time taken for disturbance to reach a point will depend on the distance and hence the time lag. Farther the point is, greater is the time lag or greater is the phase lag. And if the source is having oscillation of a particular frequency, all particles also will oscillate with the same frequency. So how does a wave frequency depend on? Wave frequency depends on frequency of the source. So frequency is a property of the source. Okay, but how fast the wave travels, speed at which the wave travels, that's a property of the medium. Frequency and speed. Speed is a property of the medium. How about amplitude? Amplitude depends on the energy given. Okay, so these are 3 points here. So if source is oscillating, what we discussed, if source is oscillating, this oscillation, same oscillation gets transferred to different points with some lag. A lag which comes, so if source is having SHM, this entire string also becomes an SHM. And this point will have a phase of 90 degree, and this phase will have, it's a different points at a particular instance of different phase. They'll not have the same phase. Okay. So and that phase we capture in terms of phi, and phi is proportional to x. So for most important part, and we'll repeat it the next week also, is this is the equation of a traveling wave. Traveling wave, unlike a wave, unlike a SHM motion, the SHM motion is only at a point. In case of traveling wave, the SHM motion is happening at all points in the space, and there's a slight difference in phase constant. And difference in phase constant depends on its distance from the source, which I think makes a logical sense. This phase constant will depend on how far the point is. What is the lag after which it has received disturbance will depend on the distance and of course the speed. And when the wave travels, when we say the crest has moved from here to here, actually what has moved? The phase of pi by 2 has shifted to this point. So what is moving is phase is moving, a constant phase is moving. So that's why we arrive at a speed of the wave by treating this to be constant. Phase has to be constant. So if I'm tracking this, so this term equal to pi by 2 indicates crest. So how far crest, when the crest is traveling, this angle has to remain pi by 2. And so we differentiate and equate it to 0, I get wave velocity, which is omega by k in this case. Now we come to EM waves. EM waves also transverse wave in nature, similar to string. And let's take a case. So suppose similar, there we have wrote an expression for displacement. Here what is oscillating? Electric field is oscillating. This expression in a way is similar, there's some difference. Let's try and understand this equation. How this, what kind of oscillation has been created? This oscillation can be created by oscillating a charged particle. If the charged particle at the source is oscillated with angular frequency of omega, electric field also will oscillate with the same angular frequency omega. So in this case, which direction electric field is oscillating? This I cap indicates the direction of oscillation, and the suffix also, we have used both the things. Actually, one of the two is enough. This indicates electric field is oscillating about x direction. Omega is the same as source, And what does minus kz indicate? This term here indicates which direction the wave is traveling. And here, since I've used the term z, it means it's traveling along z direction, a negative sign. The direction of travel is opposite to the sign. So this wave, this equation indicates electric field oscillating along x-axis, and it is traveling, oscillation is traveling along positive z direction. And if you differentiate and equate to 0, you will find we'll get dz by dt. What is dz by dt? Is vz. Velocity is in z direction. The wave is traveling along positive z direction. Omega is based on source oscillation. Electric field is oscillating with angular omega along x-axis. So we need to know which direction it is oscillating. If electric field oscillates along x direction, it induces a magnetic field in the perpendicular direction. So here we have written which direction is the, they have to be always mutually perpendicular. So this is EA, this is BY, and this is amplitude oscillation, this is along J cap. So magnetic field is oscillating in perpendicular direction. And what is important thing we notice here, whatever phase this has, this also is in the same phase. And this all comes from derivations of Maxwell. We are not going to derivation. We are just simply looking at the result. Our what are the things we require to understand? We have to understand wave equation, and we have to understand the results of Maxwell solution. So Maxwell proved that both will be in the same phase, and the proof is not so difficult. Maybe 1 or 2 hours is spent, we can understand, but that is not necessary at this stage. So it creates a magnetic field oscillating with same frequency, same phase, and will be perpendicular, which comes from the previous derivation what we have done. So magnetic field oscillate perpendicularly with omega and same phase as omega field. What is the direction of wave? Direction of wave, if in this place of z, if I written y, it would have traveled in plus y direction. In place of z, x was written, it means it will traveling in x direction. We'll come to what is the direction. So here the direction of wave is positive x-axis, and the term k is equal to 2 pi by lambda. So that's also, I think those who have studied waves earlier also will remember k is equal to 2 pi by lambda. And if we differentiate this equation and equate to 0, it gives you wave velocity. Okay, so let's continue further. So there are 3 vectors involved here. In this case, if we draw, there's a direction of oscillation of E. There's a direction of oscillation of B. E also is a vector, B also a vector, and the wave velocity. And if we can, I indicate wave velocity as C bar. 3 vectors are involved, and they have to have a proper. There's an interrelationship between direction. What is the interrelationship? Wave travels along the direction E cross B. That's the direction along which the wave travels. And this also comes from derivation. And again, we are not going, we are just trying to understand. And so what are the points he proved? First, he proved B is perpendicular in same phase. Second, he proved the direction in which the wave will travel is E cross B. Third thing also proved from this equation is speed at which will travel is equal to C naught is equal to 1 by 2. Since it is, he used the equation of electric property and magnetic property. The speed also came in terms of electric property and magnetic property. What is speed at which the wave travels in vacuum? It is equal to 1 by root of mu naught epsilon naught. And speed is also written as frequency into lambda. Frequency is based on source. Lambda depends on the, for given frequency, what lambda is automatically adjusted by the medium. So this is frequency source property, and lambda is a combination of F and medium, because medium affects speed and accordingly lambda gets adjusted. So lambda will change depending on frequency and the medium. This is, again, this one you need to remember. And when electric field oscillates with particular amplitude, there's a relationship. Since electric field creates magnetic field and magnetic field creates electric field, they are interrelated, and this is how the amplitudes are related. Compared to electric field, magnitude of amplitude of magnetic field is smaller, and this is equal to epsilon naught by C. That's the amplitude of magnetic field. So this is for vacuum. And if we use any other medium, we replace this mu and epsilon term, which is permeability and permittivity, with the term for that medium. So this is in terms of this, but if it is any other medium, it can be written as mu into epsilon naught. And mu is equal to what we have seen in magnetic properties also. Mu is equal to the term for vacuum multiplied by relative permeability and relative permittivity. So this becomes the term, but this term is what? 1 by this term is nothing but C naught, speed in the vacuum. So speed of wave in any medium is equal to C naught, which is speed in vacuum, divided by mu r epsilon naught. What are these two terms? Relative permeability and relative permittivity. And what is, we also know refractive index. Refractive index is equal to speed of wave in vacuum, which is maximum, divided by speed in a particular medium. Speed in a particular medium, if it is lower, and it will always be lower, and that's why refractive index is always greater than 1, C naught by C. So from here, if I substitute this value C naught by C, refractive index also is equal to mu r into epsilon r, whole thing square root. So refractive index depends on magnetic and electrical properties of the medium, and this epsilon r we call dielectric constant, and this term is relative permeability, which is 1 plus xi, what we have discussed a few days back. So these are all results of Maxwell derivation. So again, quickly, if we think through what are the results of derivation. Okay, it said oscillating charge particle creates EM waves. So if charge particle oscillates with angular frequency omega, it will create electric field also oscillating with angular frequency omega, and magnetic field also will oscillate with angular frequency omega. And electric field, magnetic field will be in the same phase. Then what if electric field amplitude is known? How do you find magnetic field? These are how electric field amplitude and magnetic field amplitudes are related. And we can also calculate speed at which the wave travels. In vacuum, this is the term. In any medium, this is speed. So these are the derivation, and the direction of these three terms are like this. So let's try and understand. Again, we'll take example and try and understand equation. Yes, Vignesh?
Sir, I didn't understand how both the magnetic and electric field are in phase, because one varies as the derivative of the other, right, sir?
Actually, it matches with that. We'll see the derivation is seems a little counterintuitive, but it does match. It does match. See, why does it match? Because this something. See, if at this particular instance, suppose we take this particular point. At this point, d by dt is equal to 0.
Yes, sir.
Are you following it? And so in this case, what will happen that when d by dt is 0, so when we take an area here, when we take a strip here on xy plane, so if d by dt is 0, the field on both sides, if I take if d by dt is 0, line integral of magnetic field also has to be 0. For line integral of magnetic field to be 0, the magnetic field on two sides of a small strip has to be equal. Are you getting the point here? So if I take a strip, okay, so that's a derivation, and the derivation typically is not useful for competitive examination, not necessary, and it is a little complex. But if you're interested, when you have free time, you can look at this. How do you go about derivation? But it has to be in phase. I give a small understanding. If these two sides, if I take a strip, see, if I take this strip here, if I take this particular strip, both sides value of B are not equal. If B are not equal, it will give a non-zero value of line integral of magnetic field, and that's why E also will be changed. Since here it is 0, so line integral of B also has to come to 0. It will come to 0 if both are equal, and this will become equal only when it is near the amplitude. Okay, so they are in phase. So there's a reason. It is not by fluke or something. It will come in phase, and it matches with that. Now let's see understanding of wave equation. Let's see. Suppose equation of electric field is known, and let's see from there, from equation, what are things we can understand and what are things we can calculate. So when this equation is given, what we understand from this equation? What does omega indicate here? One by one, let me ask Jaideep, where does this omega comes from? What determines omega?
The source.
Source. So the first thing we understand from this source. From this equation, can we also understand which direction is the electric field oscillating? What is the
X cap.
direction of oscillation? This also is clear. It is E naught I cap, either this or this. Both the things indicate direction of oscillation is along x-axis. Then can we also, from this equation, can we find out direction in which the wave is traveling? Which direction is the wave traveling?
Y direction.
Direction.
Y direction or minus Y direction? So when it is opposite to the sign here, when the sign is positive, can it takes a derivative?
Minus Y.
Suppose minus Y direction. And when you take the derivative also, if I take this term d by dt, what will happen? It will become omega plus k dy by dt is equal to 0. So what is dy by dt? Why dy by dt? The velocity in the y direction, it will come negative. So I understand. So this equation, what are things we can understand? Wave velocity is along negative y-axis based on this equation. It is oscillating along I cap direction. Now what else I can find out from here? Can I find out velocity from this equation? I can find out velocity. What is the speed of the wave? Omega by k. Are you clear? We are finding from this term we can find. So first we understood this equation. This comes from source. This is amplitude of oscillation. It is oscillating in which direction? It is oscillating in x direction. And three of them, there are three vectors involved, E, B, and C, and all of them like I, J, K, they form this kind of circle. So what will direction of C? It will be E cross B. What will direction of E? B cross C. And what will direction of B? C cross E. So they'll always satisfy this condition. Similar to Cartesian system of unit vectors. So magnitude of velocity, how do you find magnitude of velocity? By differentiating this term. What is the magnitude of velocity? Comes to minus omega by k. So what is omega by k? We can also write as negative of minus omega by k, coefficient of t divided by coefficient of length term. The length term could be x or y, it could be z. So omega by k minus omega by k, that becomes your magnitude of velocity. So if k is negative, I substitute k negative here, it will become a positive term. So we can understand it's minus the coefficient of t term divided by quotient of length term. That's the wave velocity. So far it's okay. Now, once I have this velocity, since the speed of light in vacuum or EM, so not light, we should use the term EM wave. Once I have this term here, if this equation is given, suppose these values are known, I can find out magnitude of C and I can find out refractive index of the medium also from this equation. Refractive index also can be found. Let's see what else we can form. Can we form equation of B from this equation? See, what are things I need to form equation of B? So can we think of how would I form equation of B? Preetham, can you think of how do we form equation of B from E equation is given? Preetham, can you think of some parameters about equation of magnetic field? Preetham?
Yes, sir. It will be perpendicular to E. So
perpendicular. First of all, it is perpendicular. No? So first, okay, what are things we know? It is perpendicular. What else we know? And do we know the direction of C here? What is the direction of C cap? What is the direction of velocity here? Just now we said, what is the direction of velocity in terms of unit vector? Which direction is the wave traveling with Preetham? Which direction is the wave traveling? Okay, just missed that point. Shreya, which direction is this wave traveling?
Y, sir. Y, sir. Y direction.
Y direction or minus Y direction?
Okay, minus Y.
So understand
Because
that
plus.
it's negative.
Yes,
so C is in which direction? Minus Y direction. The C is along J cap. How do I find out direction of B? What is the method of finding a direction B? It is perpendicular. But perpendicular to I, there are many directions perpendicular to I. So how do I find? It has to be perpendicular to this also, it has to be perpendicular to C also. And we find out, first of all, amplitude is simple. B naught by C, E naught by C becomes amplitude. So equation of this I can find out. And the phase omega t plus ky is here. B also will have same omega t plus ky. And direction of oscillation of B, how do you find out direction of B? Using this. So direction of B will be perpendicular to E also and C also. How do I find this direction? C cross E. So what is C direction? C is minus J cap direction and E is I cap direction. So J cross I is what? J cross I is minus K and minus N becomes plus K cap. So how do I find direction of B? Is this understood? I'll just go back again. Shravani, can you tell me how to find equation of B? Can you tell one by one what you understood from here? From this equation?
Sir, I actually got disconnected, sir.
Disconnected. Very good. Disconnected. Okay.
Sir, seriously.
Seriously. Okay. Very, very seriously. Okay. Bhagishri, what have you understood from this equation?
Yes.
And so what are the things you can tell from the equation, and can we arrive at equation of B from here? So are we clear when you see this equation? What are things you understand here? Are you clear about which direction is the wave traveling?
Yes, sir.
So you understand moment y is given, wave is traveling in an
Minus.
opposite of the sign. And it is traveling in negative y direction. And if I have to find equation of B, what will the amplitude of B? Equation, I need an amplitude term. How would I find amplitude of B will be equal to?
Not by C.
E naught by C. So I can find C from here. C will be equal to magnitude of C will be omega by K. I can find C from here. I can find direction of C from here. I can find amplitude of B also. And how do I find direction of, direction of oscillation is I cap. How do I find out direction of oscillation of B? I find out direction of oscillation from this. Direction of oscillation of B will be along C cross E. Is this clear, Bhagshri?
Sir.
Shreya?
Yes, sir.
Okay, so we can find out that also. So it will be along K cap. Now let's try and write an equation. How do I write the equation? This is the amplitude term. This direction term we got, where from we got direction term? This direction term we got from cross product of this from this system. So I got K cap from here, and this term will always remain same. So only thing when we have to find B, we have to find only two terms here. We need to find this amplitude, we need to find this direction. Rest of this term remains same. So that's how, if E equation is given, we can find B. And this also is very important question in this topic. So there are 3-4 questions which have come on this same topic in the mains in last 2-3 years itself. Okay, so that's a B we can find. Let's continue further. So that is how we can find B. We can, so from previous equation, we understood velocity, direction, E, B, amplitudes. And we also said when electric field is, there's energy also. And we said, see, electric field travels, and whenever in case of wave, energy also travels. In case of string also, if you oscillate, that different parts of the string also acquires energy. Similar way, though the oscillation is happening at one place, charge is getting oscillated at one place. So see, just think of it. We receive energy from the sun. Where is this energy getting created? It means the electric field is getting created at sun. And that electric field, it travels in form of wave. And EM waves, and when we receive here, when the sun rays reach here, it brings energy as well. So there's some energy also associated. And how would you calculate energy? Because since the two fields involved are electric field and magnetic field, and whenever there's electric field and magnetic field, there's energy associated. And we know this term, and most of you might have forgotten, but we should always remember this term. Whenever this is energy density. So any point, if I choose, if we're given a point, if I know what the electric field this point is, if electric field is known, so this space, small space around it, will have energy, and energy will be equal to energy per unit volume into volume of that space. Energy density is energy per unit volume, and this is what energy density is, and this we had derived earlier. This we derived from capacitor, and this term energy density in the magnetic field we derived from the inductor. And this is the terms we should remember, 1/2. And you know, in case of electric field, epsilon comes in the denominator. So in case of energy, the position of epsilon naught and mu naught becomes interchanged with in compared to field formula. So this is energy density. It's okay. So when we look at this figure here, this is a point here. If I choose this particular point on z-axis, this gives you at this instance electric field, and this gives you magnetic field. If I choose this point here, at this point, at this instance, electric field is also 0, magnetic field is also 0. And where both are 0, this is kind of a node. We call this as a node where both are 0. And where both are maximum, it is called anti-node. and T node. And we'll come to that again later. So which point, what will the energy at this particular point here? Vignesh, what will be the energy of this point? If I take a small space around a node, what will be the energy contained along this point?
0.
0. And where would the energy be maximum? Are you able to spot the point where energy will be maximum?
Like when both of them are maximum.
Both are the maximum. So if I take this particular point here, energy is maximum. And in between, energy is varying as a sine function. And what will happen as the wave travels? Right now, this point has little later amplitude of at this point will keep decreasing, and after some time this may also become a node. So energy density at a point is varying. Energy density will keep varying, but this is how we can calculate. And both electric field energy and magnetic field energy, both they reach their maximum simultaneously because they're in phase. So that is something is linked to their being phase. So this point will have maximum energy. Disha, have you understood this point?
Yes, sir.
Okay. Both forms of energy are maximum simultaneously. So energy related to wave, that's the equation for density. Now, so at a particular point, what will happen? At any point, E value will keep on changing, B value will keep on changing. So when we talk about it, they'll be changed very, very rapidly. See, this frequency are of the order of millions and billions, and this will change very rapidly. So instantaneous energy is not so much of significance. Average energy is more important. What is average energy density due to electric field? And how do I calculate average energy density? We have seen earlier also, and I'll not go into too much of detail. Average energy is equal to half the maximum energy. Whenever in case of AC also we have seen, and the same thing happens in case of SHM as well. So what will the average electrical energy? It will be half of the maximum energy. It comes from the term, if I take 1/2, 0 to t, any sine square function, this term this comes to 1/2. And that's why this comes equal to, so what will the average energy? Average energy will be half of the maximum energy density. Similar thing will happen. So at a point, so what is average electric field energy? Yes, this is average. And similarly, magnetic field also will be, this will be average energy, half of its maximum energy. So what is the total average energy? It has two forms of energy. Total energy will be sum of the two energy. But before I do so, even let's look at this energy. This is 1/2 mu naught B naught square. So basically we are talking about, first we are calculating for vacuum. But this term also we know B naught is equal to E naught by C. So let's put this value 1/2 4 epsilon being same. In place of epsilon naught, we have term substituted E naught square by C square. But even C also is equal to, C square will equal to 1/mu naught epsilon naught. So I have substituted the value of C square here. When I substitute this value, mu naught gets cancelled out, and what we get is this term. So what do you understand from this two? Can anybody make a statement? What you observe from this? Can you make a general statement based on what you see on the screen? Anyone? Anyone, can you make a statement? Can you observe something here? This energy is equal to this. So what we understand from here? Okay, energy is equally shared between electrical and magnetic form. So whatever at a point, if an average, if I calculate average electrical energy and I calculate electrical average magnetic energy, both will come equal. Okay, so this is something, it is equally shared between electric and magnetic form. So average total energy, if I calculate average total energy, will be sum of those two. Average is very similar to what we do. So average total energy, add these two up. So since these two are equal, average energy becomes equal to twice of this. So average total energy is 1/2 epsilon naught E naught square. So we can also say what is the average energy. And you recall in case of SHM also. What is the total energy of SHM? Now the total energy we also write as 1/2 Ka square. What does this term indicate? See, total energy consists of kinetic energy and potential energy. So there also, what is the total energy? I can say the total energy is equal to maximum potential energy, or total energy equal to maximum kinetic energy, 1/2 Vm square. So here also we are saying the same thing. What is the average total energy, it is equal to maximum electrical energy, 1 by 2 epsilon naught E naught square. Very similar to SHM motion. So average total energy equal to maximum electrical energy and maximum magnetic energy. When I use term epsilon naught, it indicates maximum energy. So maximum energy will be equal to 1 by 2 epsilon naught E naught square. Okay. Dhanshri, is it going into your head so far? You understood this point also?
Yes, sir.
Both energy as an equal form. So total energy, we can remember this is the form. And similar to, see, this is electric field is oscillating with amplitude of E naught. Can someone think what will be E RMS value? What is RMS? This also varying as a sine function. E RMS also can be written similar to what here, and it can be written as E naught by root 2. So if I have to write in terms of RMS form, E RMS also is amplitude by root 2, same thing. So what will RMS value in place of this is the term we can use. So average total energy in place of epsilon naught. If I substitute root 2 into E RMS, total energy become equal to epsilon naught into E RMS square. So these are the two terms in terms of energy we should understand. And same thing is valid in case of one is in terms of amplitude and second is terms of RMS value. And very similar to AC and similar to current SHM equation. So these are all the points we need to remember. And let's come to one more thing. Once we know energy, there's something we know where we keep receiving energy at a point. So we have defined term intensity earlier. Let's come back to that definition again. What is intensity? Intensity per V is calculated over a surface. It is, we can use a term called energy passing through a unit area in unit time, or energy flux through a unit area in unit time. Or in intensity, if a total energy passing through an area is equal to E divided by A divided by time. And the energy per unit time, that becomes power. So it is, you can also say what is intensity. Intensity is power through that area divided by power divided by area of. So if EM waves are falling onto the surface here, so intensity. So if how would we calculate intensity? Let's say what we have calculated so far, we have calculated average energy density. So at any point where waves are traveling, if the EM waves are traveling here, so this point, if you have to calculate what is the average energy at this point, average energy at any point, assuming it is traveling parallel, is what? What is the average energy? You recall, somebody recall from previous sheet, what was the average energy in terms of electrical field? Average energy was equal to maximum electrical energy density. Average energy density is how much? Average energy is equal to maximum electrical energy density. What are that equal to? Maximum energy, and just the formula 1 by 2 epsilon naught. When we talk maximum, I have to take the maximum value of E, amplitude of E. This is the average density. So when wave is traveling, its energy also is traveling. So you tell me what length of wave will pass through. See what length will pass through this area in 1 second. So we are talking about intensity. Intensity, if I take this area as 1 unit, how much energy will pass through? So energy, how much energy will pass through the area in 1 second? We have done this flux something. Can someone think of what is the, how do we calculate how much energy will pass through? So if we think of wave, it's like energy packets which are traveling. So this different points are different energy. As the wave is traveling, this energy also is traveling. In 1 second, energy, if I take a part of wave which is at a length of c, all these things, all energy forms of energy or wave form which is within the length of c will pass through the area in 1 second. So the entire energy which is contained within the length is equal to c will pass through the area. Vikram,
Yes, sir.
are you following?
Yes, sir.
So this something. So what is the intensity? Intensity is this entire energy contained in this volume. I'm converting energy into energy density into volume. This entire, what is this volume equal to? Area cross section is A and length is equal to C. Area is equal to 1. So what is the density I know? So to calculate energy, I need to multiply energy density. It is energy per unit volume. I need to multiply by volume. Which volume should I multiply with? Area into length. Area is 1 because I'm calculating energy passing through unit area into C. So if you understand this part, so wave within a distance of C will pass through the unit area. So all the energy which is contained within a distance C from the area will pass through it. What is intensity equal to? Energy contained within a unit area multiplied by C. So intensity is equal to average energy density into C. So I can write intensity. This is the expression for intensity. Intensity is equal to average energy contained in volume C. Energy contained in volume C. So what is energy contained in volume C? Energy per unit volume into C. 1 by 2 epsilon naught E naught square into C. This is in terms of amplitudes. And if you have to write in RMS value, in E naught square by 2 is equal to E RMS square. So this is intensity.
Sir,
yes?
yeah, sir, is C just like a regular variable, or do you mean C
Yeah, tell
in
me.
terms of
We have used this term C at least 4 or 5 times before this slide. Can you think of what does C indicate here? Anyone else? What does C indicate here? What does C indicate here?
Speed of EM wave.
Yes, speed of EM wave. And then that's why
Yes,
it will
sir.
passing through 1 second. And C is speed of EM wave. That's C here. And all through, if whenever I use term C naught, then what would C naught indicate? Speed of wave in vacuum.
Okay,
And if I
sir.
use C, it's speed in other medium. Okay, so
Got
that's
it,
the normal
sir.
convention. And C is the very common expression notation we use. Notation may change, so we should never get fixed with a particular notation. But some of the common notation we should be aware of. More so, we should understand what does it imply. Is this clear? What is this intensity? So just look through all the things. We have known this energy density earlier also. If we had remembered energy density, what you have done without much of memorization, you can, if you understand, it becomes easy to write this expression without the need for memorization. If you don't understand, everything becomes a formula. So see that if you get through the logic, the flux kind of thing, and we have used this concept in case of fluid mechanics also. They also use the same thing. What is the volume of liquid which will pass through a cross section? Volume flux, mass flux. And so the same concept comes in mass flux, volume flux. Now we are using energy flux. How much energy will pass through? All energy contained within the length equal to C will pass through. So that's the equation. And we also define this term intensity. And if rays are falling like this, just understand here, if suppose you stand in the sun and the sun is vertically above your head, sun rays are coming like this. Since the distance is very far, it is like parallel EM waves are coming. If I place a sheet which is perpendicular to the direction of travel of wave, it receives certain energy, but if I change the angle, the energy level will change. Intensity will change if I change the angle. So intensity through an area is a function of angle between area vector and wave velocity vector. So we define another term pointing vector is nothing but intensity. This pointing vector, if some of you recall current density, pointing vector is a vector at a particular point. And what is the direction of this vector? The direction of vector is along the direction which the wave travels. So if waves are traveling like this, so if I have take pointing vector anywhere where the wave is traveling, the direction of this pointing vector is this direction. So direction is similar to current density. Current density, what is the direction of a vector? In the direction of flow of charge. There also pointing vector, direction is direction of wave travel, and it has a magnitude equal to intensity. And so what is pointing vector? This term, if I give a direction in terms of wave direction, so pointing vector if I have to write, I could have written pointing vector as like this, intensity 1 by 2 epsilon naught E naught square C, which direction? C cap. Or I could have written C. That becomes my pointing vector. Not very commonly used, but yes, this definition is there. And anything which comes, moment you think of pointing vector, just think of intensity. is intensity with a sense of direction. It is intensity vector in direction of EM wave. That's Poynting vector. Let's intensity in some other form also, and like sun. Sun also is in most cases source of energy is like a point source of energy. The intensity due to power source, which is emitting EM waves in all directions. So what are the two things we can think of which acts like a point power source for distance for objects a large distance? One, of course, is the sun. The sun also is a source of energy. But whatever, when we talk about power of sun, what does power of the sun mean? See, when you have a bulb, we say 100-watt bulb. 100-watt bulb actually indicates the power it consumes. It doesn't mean it radiates EM wave of power equal to 100 watts. Sun also, when you talk about power, it is amount of heat, the amount of energy radiated in a second in form of EM waves. So intensity, unless we calculate. So suppose we have like sun or a bulb, power is P. Can we calculate intensity? So a source emits EM waves, has a power of P, which will spread out in all directions. So how much energy is being spread out in 1 second? P amount of energy in form of EM wave is spreading out. So can we calculate intensity? So if I take a concentric shell, I've taken a concentric shell of radius r. I hope all of you easily understand if I calculate intensity at any area lying on the surface of the spherical shell. Everywhere intensity will be same. Because all area on the spherical shell are perpendicular to direction of travel of wave, and equal amount of energy will pass through per unit area per unit time. So intensity at all points on concentric spherical shell of radius r will be equal. Okay, so it's a function of only a distance r. What is power passing through? Whatever power it radiates in 1 second through all this area, if I calculate what is the power, which is energy which is passing through entire spherical shell. Entire spherical shell energy passing in 1 second will be equal to P. Thus energy which is passing through in 1 second. And this will be uniformly distributed all over the surface. So power passing through the surface of spherical shell is same as the power which is radiated. So what is radiated, the same amount will pass through. Whatever energy radiated in 1 second, same energy if I take a spherical shell which encompasses the whole source, same amount of energy will pass through, or power will be same. So what is the intensity? Intensity is power by area. So power by area, so this is the power which is passing through the area. And what is the area of a spherical shell? Area of a spherical shell is 4 pi r square. So intensity at a surface at a distance r from a source emitting a source of power P will be equal to P by 4 pi r square. So very simple expression. So let's take as in case of bulb. So this is what I done in power. This what is P here? This is a power radiated in form of EM waves. Now come to like a bulb. See, bulb also when you say 100-watt bulb, 100-watt indicates that's a input power. But what is output in form of EM wave? Output is not always equal to input. Output is equal to efficiency into input. So energy radiated or power radiated in form of wave in EM waves will be equal to efficiency times input power. So this is the power radiated by bulb in form of EM waves if efficiency is not 100%. Efficiency times power input is equal to power output. Okay. So that's all the theory what we need to cover today. So rest all is, so we'll go through some simple applications of the same. Let's look at one by one, and all questions I'll not solve completely, but I think these are most of the questions are of the nature of use of formula, and we identify formula is easy to calculate. Moment we look at this equation here, this wave function for electric wave is given like this. What is the speed of wave? So moment I think of speed of wave, how would I calculate the speed of wave? Which part we use to calculate the speed of wave? We take this term is equal to constant and differentiate. That's how we calculate speed. And that is something what we discussed. If I differentiate, what do I get here? If I differentiate with reference to time, you will get into t into 10 to the power 6 dx by dt, which is the speed of wave, equal to 9 into 10 to the power 14. So what is speed of wave? This term divided by this term. So we can also, that's why I write study of wave is equal to omega by k. Okay, so very easy. The speed of the wave, that's what we need to use. So you are just understanding the formula. Second question, suppose you have to solve this question here. Relative permeability of the glass and all those things are given. What is refractive index of the glass? Now to think of what is refractive index. Do we recall refractive index? Refractive index is ratio of speed in vacuum divided by speed in that medium. That is refractive index of the medium. We compare this, it is because of speeds. And we have written this term. If we write this expression, this term is equal to root of mu r epsilon r. Relative permeability, relative permeability, whole thing is square root. So these values are given. What is 3 by 8 relative permeability? Value of mu r is given. And dielectric constant epsilon r is given. We can easily find out refractive index. So what should come to your mind? Refractive index is the ratio of velocity of EM wave in vacuum divided by velocity in that medium. And what is speed in vacuum? This is the formula. And for C, this is the formula. And we simplify, this is the term we get, and substitute, we get your answer. Now come to the next question. Electromagnetic wave of frequency, this certain frequency, it passes from vacuum into a dielectric medium. So when it was traveling in vacuum, what change will happen? Will the speed remain same or speed change when it travels from vacuum to some other medium? And which you see which can happen. See, suppose a slab of glass. Now a glass slab is lying here, and sun rays radiation falls onto this. So earlier it was traveling in vacuum or air, and now the waves start traveling in glass. So will the speed here, this speed was C naught. Here the speed will become C. Speed will change. Okay. And what the speed C will be equal to? This C will be equal to what? C will be equal to C naught into, sorry, it will C will be equal to C naught divided by. So in this case, what will happen is speed will become half. When the speed becomes half, the question is asking what will happen to wavelength and frequency. So can someone tell, will the frequency change? Frequency depends on the source. When it moves from one medium to other medium also, frequency still remains what was created at the source. Frequency does not change, but speed is changing. And what is speed is equal to? Speed is equal to, because when speed is equal to frequency into lambda. So speed is changing, this does not change, this depends on source. So what will happen if speed becomes half, the lambda also has become half. So we could have written as C naught is equal to F into lambda naught, and C is equal to F into lambda. Yes, Vignesh?
Sir, what about the mu value, sir?
See, when it is not mentioned, you have to assume it is a non-magnetic medium. So if nothing is mentioned about magnetic properties, mu depends on magnetic property. Ideally, we should have mentioned non-magnetic medium. When you say non-magnetic medium, it means mu r is equal to 1. So it is something equal to just another way to understand is, see how do we calculate speed? See this you know, remember this is a kind of wavelength. And in oscillation, if frequency is f, this wavelength gets repeated f times in 1 second. And that's why the speed becomes equal to lambda into f. So when the speed becomes half, it is like this. Number of waves are same, but each wavelength has become smaller. If wavelength becomes half, frequency remaining same, speed becomes half. The wavelength has become half, frequency remains same. The reason is frequency is determined by frequency of the source. So here also the sun rays are coming from the sun. It is frequency created by sun. Same thing, when it travels, the frequency remains same, wavelength changes. Even a simpler question. The electric field oscillates at a frequency and amplitude. So what is this term? If we use our normal notation, this term gives amplitude of electric field. So this term is epsilon naught, E naught. What we have to calculate? I have to calculate B naught, amplitude of magnetic field. This also very direct question, direct formula. This is based on, sorry, I've written wrongly. This that's why I was wondering where this equation has gone. Speed of waves equal to wavelength into frequency. I typed this here. It is pertaining to previous question. So in this case, pretty simple. What is B naught equal to? B naught is equal to E naught by C, and C value is 3 into 10 to power 8. So very simple calculation, this one. Look at something similar, but this is a little more interesting. A wave of frequency travels along x-axis. Travels along x-axis means what? The C is equal to I cap. That's how we can summarize this statement in terms of direction. At same point and same instant, electric field E has a maximum value of 750. Okay, so E value is given. E is equal to 750. And which direction E is? E is in the direction of J cap. What we need to find? We need to find B. So first of all, what is the magnitude of B? I can find magnitude separately and direction separately. B will be equal to magnitude of E divided by C. Okay, and wherever C is not given, you can take as a vacuum. The magnitude of C will be equal to 750 by C. That's the magnitude. And if you multiply by 10 to power 6, that many mu T. How do I find direction? For finding direction, I have to use this. So direction of B will be along C cross C cross E. So direction of B, C is direction of B will be along C cap cross E cap direction. What is C cap cross E cap direction? C cap is I cap cross J cap, which is equal to K cap along Z direction. So are you clear? This is simple applications. This also similar question. It also free space is traveling along X direction. Traveling X direction means direction in which the wave travels is I cap. At a particular point in the space, E is given. Find the magnetic field. It's also similar repeat of similar question. You can easily calculate using this. Next question. From a power of so and so, we have to calculate intensity. Can we calculate this intensity? Rahul? Shriya Rao? No response. Gayatri?
Yes, sir.
Can you tell me how to calculate intensity here? Intensity is not something we come across first time. What would be the intensity when power is given? So see, just visualize here. So this is something, see, there's a source of power. We need to calculate intensity at some point here, which is at a distance of 1 kilometer. How can you calculate intensity, Gayatri? What will the intensity? So if I have a unit area, intensity means if I have a unit area.
Power by area, intensity is equal.
At points which are at a distance of 1 kilometer will be same. And what would that intensity be? Energy crossing per unit area per unit time. Energy is this up. And you should understand also where the formula comes from. And there's no need to memorize this formula. Intensity is P divided by 4 pi r square. Gayatri, are you able to understand? Do you need to memorize this formula, or
No,
have you understood how to get this term?
I have understood, sir.
Understood? So we should have lesser reliance on memory. If you understand things, it becomes much easier to memorize and you make less mistakes. So this is pretty simple question. So intensity of wave, we have to calculate. Power source is given, P is given. So I'll substitute in whatever SI, since the answer is an SI unit, 12.56 into 10 to power 3 divided by 4 pi. Distance is 1,000 meter, 1,000 square. We can easily calculate that it will come into watts per meter square. That's a unit of intensity. power
Sir?
per unit area.
Sir?
Yes.
Sir, even if we use half epsilon naught E square C also, we should get the same result, right, sir?
But where is the
I mean,
amplitude
we
given?
can't use it
Suppose
here,
in
but
this question, they ask what is the amplitude of field here? Then I can calculate. If I have to calculate, see what will happen when the ray travels. Will the amplitude of electric field remain same as it keeps traveling?
yes.
Will the amplitude remain same or keep
Oh no,
changing?
ideally it won't remain same.
It won't remain same. It will keep on diminishing. Okay, energy density is decreasing. Now, and how is intensity related to amplitude? Remember, what is intensity is equal to? Average energy density into C. Energy contained in volume C, that is intensity.
Yes, sir.
How would I relate intensity to? We'll come to that question also. In terms of amplitude, I could have written average energy is equal to maximum electrical energy. Maximum electrical energy is this one into C. So what I notice as intensity keeps reducing, E also will keep on reducing. I could have written this as power by 4 pi R square. What I notice, amplitude is proportional to 1 by R. Is this clear?
Yes, sir.
Okay. Next one. So magnitude of Poynting vector, electric field vector, and E. So when electric field vector is given and it is not given amplitude, so we have to assume it is RMS value. How are they related? They are equating magnitude. So do you recall what is Poynting vector? What do we have to take as Poynting vector as here in this case? What is Poynting vector here in this case? Pranav, can you tell me what is Poynting vector? Do you recall? Pranav? Not able to recall? Poynting vector is nothing but intensity. So this is a relationship between intensity, field, intensity and field. And what is the relationship? What is intensity equal to? Poynting vector is magnitude of Poynting vector is equal to intensity. How is related to field? It is related to 1 by 2 epsilon naught E naught square C. It is in terms of amplitude, but in terms of RMS value, it is epsilon naught E square C. And this Poynting vector has been given as, what is the Poynting vector given as S. So can we find this value here? Only thing what has been done here, the C also has been written in which form? The C also has been written in form of 1 by mu naught epsilon naught. So what I have written here, something like this. The intensity is this, it is using that equation only, and you can easily find. Is equal to epsilon naught E naught C. But substitute C is equal to 1 by mu naught epsilon naught square root. So in place of C, if I write 1 by root mu naught epsilon naught, and I is equal to what? I is equal to is, what is I equal to S here? Are you clear why I'm not taking this term? Why I'm taking this term here? It doesn't ask electric field amplitude. It's asking whenever say the amplitude is not specifically mentioned, we have to assume it is RMS value. Okay, lamp power radiates power P naught radially in all direction. Amplitude at a distance R. Just now I mentioned. Can you all write this expression for yourself? Amplitude of electric field at a distance R. So all of you can just see how many of you can write. Just and write this expression, see what is the answer you get. And as soon as you get the answer, please raise your hand. Let's see how many of you can write this expression. Actually, I have written this expression just a few minutes back. That's good. RH. Which option are you getting, RH?
Second, I think.
So which basis of how do you do that? Like we power, we know, see what should come to our mind here. We know relationship between intensity We know in this expression, what is intensity equal to this intensity, and intensity is related to amplitude of electric field. So once I have this expression, and if we understand where the expression comes from, it becomes easy. The power is given this expression. If you simplify this expression, you get your answer. Yes, any question? Rest of the people, any difficulty in this? And where does this intensity come from? Intensity is equal to power by area of the shell on which we are calculating intensity, and intensity is equal to energy contained in volume C, energy density into C. And what is the energy density? Energy density is equal to maximum, average energy density is maximum electrical energy or maximum magnetic energy. That's similar to what we have in case of SHM oscillation. When we talk about what is energy of oscillation, 1 by 2 Ka square, maximum potential energy or maximum kinetic energy. So in place of potential energy, kinetic energy, we have electrical energy and magnetic energy. So similar way we can solve these questions. Okay, so we'll continue from here in the afternoon as well. A simple application of basic formula. So I'll stop here and we carry on from here in the evening session.
Sir?